This is just a quick video to talk about some distance scales for the solar system and give you a start on developing a concept for how widely spaced objects are and some relative sizes of objects. So I have some data here I've collected from NASA and other sources. Diameter of the sun, some million kilometers. Diameter of the Earth, 12,000 kilometers. Average distance of Sun to Earth and average distance of Sun to Neptune, our outermost planet. Since Pluto is a dwarf planet, I'm just going to go to Neptune. There is a cloud of cometary material called the Oort cloud surrounding the Sun, and it does not have a sharp edge, but roughly, let's say that the edge, and I should put edge in quotes, big quotes or something. This is not a sharp edge, a definite drop off. Just fewer and fewer comets the further out you go. But we have about 100,000 astronomical units to that location. That turns out to be 10 trillion kilometers, an order of that. Approximate distance to the nearest star other than the Sun, that would be Proxima Centauri. Didn't have room for the Tauri. 4.02 times 10 to the 13th kilometers. Notice that the Oort cloud is the same order of magnitude to the outer reaches of the Oort cloud as to the nearest star. Our Sun gravitationally controls a volume of space that roughly is halfway to the nearest star. And then approximate distance to the center of the Milky Way, rough estimate 8 kiloparsecs, 8,000 parsecs, 26 light years, 26,000 light years. Forgot my little K here. 26,000 light years. And in terms of kilometers, we're getting up to 10 to the 17th kilometers. If you need help with powers of 10, please watch my video on powers of 10 or scientific notation. Okay, let's get into some scales here. I'm choosing to represent the Sun as the size of a basketball, that you may be familiar with, something you can hold in your hands, roughly 24 centimeters in diameter. I'm going to talk about these objects just using the Sun as the size of a basketball. What would these other things be represented by? So here's our Sun, 23.8 centimeters in inches. That's 9.4 inches for the diameter. For the Earth, 0.22 centimeters or 2 millimeters, 0.09 inches, extremely small, 100 and some odd times smaller than the Sun, 109 it might be. But average distance of Sun to the Earth. So if the Sun is a basketball, you place that down at some location and you walk 84 feet away. You put the basketball down in the grass and you move 84 feet away. You would now be standing where the Earth would be positioned in the solar system in this scale model. The Sun is the size of a basketball. You put that down on the ground. If you're in the United States, you move 84 feet away. If you're in a metric country in the world, go about 26 meters away from that basketball. A little further out to Neptune. So we have the basketball in place, and now to get to Neptune, we need to go 771 meters away from our basketball, and I have converted that into miles in the English system, a half a mile away. So you put the basketball down a half a mile away, that would be the typical location of Neptune in its orbit. It's not a circular orbit, but it would be representative of a half mile away to locate Neptune. To the outer reaches, edge takes up less space than the words outer reaches, but to the outer reaches of the Oort cloud, if the Sun is the size of a basketball, 2 million meters away would be our outer reaches of the Oort cloud. That's 1,600 miles. That's not as far across as from Pacific to Atlantic Oceans across the United States, but it's a considerable portion of that distance. The sun is the size of a basketball. This gives you a sense of the space that the sun's gravity is controlling. And to our nearest star other than the sun, Proxima Centauri, if the sun is the size of a basketball, now you have to go about 7 million meters away. And now 4,280 miles, 4,280 miles is the separation of the sun and this nearest star other than the sun. There's a tremendous distance between stars relative to their sizes. We have this basketball at one location, another basketball for Proxima Centauri roughly, and those two basketballs are separated by 4,280 miles, or if we go to kilometers here, roughly 7,000 kilometers. 7,000 kilometers. And I don't know, can you think of any object in the solar system that has a size, some dimension that's about 7,000 kilometers, or 7 times 10 to the 6 meters? Well, if you're coming up with the radius of the Earth, you've done well. This is about the same as the radius of the Earth. It's a little bit larger, but it's about the same as the radius of the Earth. So if we'd have a basketball in the center of the Earth, another basketball on the surface of the Earth, that would represent the separation of these two stars. There's tremendous distance between stars. When galaxies collide, it's very, very rare that two stars of the galaxy collide because of this great distance between them. Gas and dust will collide, but not the stars individually. Approximate distance to the center of the Milky Way. So this is getting hard to visualize. Basketball in one place, 27 million miles away. We have the black hole at the center of the Milky Way galaxy. So there's a huge distance. We are nowhere located close to the center of the Milky Way galaxy. In terms of kilometers, 4.4 roughly times 10 to the 7th kilometers. So 43 million kilometers away from the center of the Milky Way galaxy when the sun is represented by the size of a basketball. Now I'm going to go a little bit different here. If we would say that the sun is represented not by a basketball, but by a dot that's 1 millimeter wide, and I happen to measure the dot at the end of the sentence, this is roughly 1 millimeter here. So if the sun is this size, our nearest star would be 18 miles away. 18 miles away, and more kilometers than that. If you multiply by 1.6, you get the number of kilometers. I didn't bother to do that. But a huge distance. Just again emphasizing the stars are very far separated from each other. The stars are very far separated from each other. Sun is this dot. We have another dot 18 miles away from this one, and that's the other star. So huge distances, astronomical distances involved in the study of astronomy. So you might want to replay this, and hopefully I had everything on the screen the whole time, but go back and pause where you need to pause and think about the huge distances in astronomy.